All right. Well, I'm streaming. So if you want to, you can pull up my YouTube channel. It's gonna lag. So once again, you can always just follow along like normal notes on the board as well. So you can go to youtube.com/NickLol if you want to stream.
It's restricted.
1 second. I'm gonna make it unrestricted in just a second. I'm making it unrestricted right now. Alright, if it's not working, hit refresh. Alright. Do we have... Alright, so now that we're getting started, if you can, do we have a volunteer to read... Alright, everybody, no one should be talking except for Jasia.
Okay, a triangle is a polygon with 3 edges and 3 vertices. The sum of
Alright.
The sum of the angles in a triangle are 180 degrees. Triangle angles are always in degrees. Yeah, degrees of right triangle is a triangle with a right angle 90 degrees.
Yes, ma'am.
You must be able to apply.
Sorry, that must be able to.
Given both sides or a side and the hypotenuse, you can find the missing side.
Okay, so Pythagorean theorem: a squared plus b squared is equal to hypotenuse squared. So, how would we apply the Pythagorean theorem to find for this triangle? How can we find h? Well, yeah, but how? What's the process?
Oh well, you can do a squared plus 6 squared.
Yeah, so 6 squared plus 8 squared, what does that equal?
So a number 100.
Well, but h squared, but alright, the leg squared plus the leg squared equals the hypotenuse squared.
Yeah, I know.
So 6 squared plus 8 squared equals h squared. 36 plus 64 equals h squared. 100 is equal to h squared. Root both sides. 10 is equal to h. And then, because 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So, once again, it's not, so technically it's not a 3, 4, 5 triangle, but similar to one, right? So the proportions are exactly the same. So even though it's not, even though the side lengths aren't 3, 4, and 5, the proportions are exactly the same. I want you to think about this. If the proportions of a triangle are the same, the ratios between the sides are the same. Think about that. All right. Any other comments or things people want to add before we're done with the Pythagorean theorem? All right. So, similar geometric figures have equal measure angles, angle measures, and proportional side lengths. I need you to start, in order to understand trig functions. All right, Roy, eyes open. In order to understand trig functions, you're going to need to think of angles in a slightly different way. Okay? You guys are used to functions. And normal functions are y is equal to 2x, y is equal to x squared. Okay. But like the audio is coming from right here. Nah. I think that. Nah, fam. Alright. So traditional functions that you're used to, y is equal to 2x. You take your input, you multiply it by 2. Y is equal to x squared. You take your input and you square it. Trig functions, I need to think about it conceptually, takes an angle, takes an input, the input has to be an angle. Then you find the reference angle of that angle so that that angle is acute. Alright, which means less than 90. Then you take that acute angle and it becomes one of the angles in a right triangle. Then, because once you know one angle that other than the hypotenuse of the right triangle, you know the other angle, because that's 180 minus 90 minus your angle, that's equal to the other angle. Once you know all the angles in the right triangle, you'll be able to determine the proportions of the side lengths of the right triangle. And what trig functions are the proportions of the side lengths of a right triangle. Trig ratios, trig functions, take an angle input and take the proportions of a right triangle as an output. Here, don't throw away the markers, because if you put them face down, like put them cap down, and have them wait for like 3 days, they that.
3 days.
Yeah.
I'm so done. I am so done.
What was that? Yeah. That's those markers, they add up, you know. Okay?
He said, the man said after 3 days, hey, Mr. Rowan, I'm going to throw one by one.
Oh. 2. Oh. 3. Oh. 4. All right. So here, theta. Okay. Theta is the angle of interest. All right. We're gonna have label all of our side labels relative to this theta. The side across from theta we call the opposite side. The side touching the angle that's not the hypotenuse, we call that the adjacent side. So opposite, adjacent, and the side across from the right angle, we call that the hypotenuse. 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 So this is the ADJ, that stands for adjacent. OPP, that is the opposite. All right, so, yes, Dylan?
Is there any way that you can turn the label?
Nope. I mean, you can, once again, you can also just, like, follow this like normal notes, and the live stream is just an additional benefit that normally wouldn't have, right? So if it's just marginally better by any small amount, it's still an improvement versus just having this on the screen. Right? So, the sine of theta, alright, is the, and by the way, we call these trig ratios sine, cosine, tangent, cosecant, secant, cotangent. We have, trig functions are just the ratios of the sides of right triangles. They have names because we have to name them. You have to have some sort of name to have them. The names for them are relatively meaningless. I mean, it does have like some Latin derivation, but there's no mathematical reason why sine is called sine. It's just trig functions are the ratios of right triangles, and we have to name a name for it. Time. Fine. All right. So the sine is the opposite side over the hypotenuse. The cosine is, so, and then notice your input is an angle, your output is a right triangle ratio. Your cosine is the adjacent over the hypotenuse. Cosecant, CSC of theta, is going to be the hypotenuse over the opposite. What do you notice? Do you notice any similarities between sine and cosecant? Just flipped. So, in fact, sine is related to cosecant. They're called reciprocal trig functions. So the cosecant is actually equal to 1 over the sine of theta. Okay, the secant of theta, SEC, is equal to the hypotenuse over the adjacent. And that's equal to 1 over the cosine of theta. Yeah, I'm going to slide over and give you guys some time. Now I'm out of the way. Well, that really is big. Yeah. I think the video quality is increased by this really fast. And that's pretty high quality. And that, all right. Am I good to clear? No. Okay. All right, clear annotations. Yes? No? All right. Tangent of theta, that is the opposite over the adjacent. This is equal to the sine of theta over the cosine of theta, by the way. And the cotangent of theta, that's equal to the adjacent side over the opposite side. So that's equal to the cosine of theta over the sine of theta. It's also equal to 1 over the tangent of theta. So if you have 1 over 1 over a fraction. The numerator and denominator of the fraction flip. So 1 over opposite of adjacent over adjacent flips the numerator and denominator. Adjacent over opposite.
You resetting the time there, Jake?
Yes, I was.
You have your Apple Watch doesn't update time, daylight savings time itself.
Yeah, I have to.
You have to manually do it.
Yeah.
You have to wind your Apple Watch every week to make sure that the gears work.
In case, I'm still from the hour.
Yeah. All right. Clear annotations. Yes. No. You could. Is this live stream? Are you able to pause it and go back? Okay, so yes, I'm going to clear annotations because you can go back. All right, so once you know what sides are relative to angles and what those ratios are, it's just a matter of plugging them in. Yes, Dylan. What was that? Probably because that causes the least amount of disruption as far as having a actual time change. It's probably that they probably pick the time to maximize the number of people that go to bed and then wake up and have the time skip happen right then. Probably they use a probability distribution of the human population, figured that more people were asleep at 2 than asleep at 3. No. So, daylight savings, it's due to, I believe it's due to farmers. Like, I believe they just kept the rule based on farmers, like in the 1800s, and for to save fuel and stuff like that. Yeah. I don't know. We're gonna move on though. Watch your language. Brandon. All right. So we're gonna once again go through the proofs of the special right triangles that we did last Friday. But we're going to do them again because I think they're cool. And also, we're kind of redoing our notes on right triangles.
There's a die on there.
All right. All right, so the hypotenuse value is 1, and our angle values are 45 degrees and 45 degrees. Because our angles are 45, and both angles are 45, because the angles are equivalent, the sides opposite them are also equivalent. Then, using the Pythagorean theorem, we can determine that x squared plus x squared is equal to 1 squared. X squared plus x squared is 2x squared. 2x squared is equal to 1. Divide each side by 2. X squared is equal to 1/2. root both sides. X is equal to square root of 1 over square root of 2. X is equal to 1 over the square root of 2. Now, x to get the radical out of the denominator, rationalize the denominator, what you can do is multiply by root 2 over 2. So you have 1 over the square root of 2 multiplied by root 2 over root 2. Root 2 times root 2 is 2. 1 times root 2 is root 2. So x is also equal to root 2 over 2. So x is equal to root 2 over 2, and x is equal to root 2 over 2, because x is equal to x. All right, we can turn those volumes off in the back. So now that we have the measure of our special right triangles and what the sides are equal to, we're going to find the trig functions for 45-degree angles. So what's the sine of 45? So the sine of 45 degrees. What's the opposite side? So let's look at this 45. What side is opposite 45? What's this? This is the length of x. What's x equal to? Root 2 over what? Root 2 over 2, so that's the opposite side. Root 2 over 2, that is the opposite side. And what's in the denominator? 1. Why? Because 1 is the... What's 1? The hypotenuse. And the sine of any angle is the opposite side over the hypotenuse. So root 2 over 2 over 1 is just root 2 over 2. That's equal to the sine of 45. That's the opposite. So that's... What's anything divided by its... So that's equal to the sine of 45. Alright, so what's... I mean, anything divided by 1 is itself. So that's kind of why it's kind of helpful. That's why it's helpful to have a hypotenuse of 1, because it makes that division pretty easy. The cosecant of 45 degrees, that's equal to 1 over root 2 over 2. 1, the hypotenuse, over root 2 over 2. What happens when you have 1 divided by a fraction? What's going to happen to that fraction? Flip it. So that's equal to 2 over root 2. Yep. You can use 1 over root 2. So this is also equal to multiplied by root 2 over root 2. That would be equal to 2 root 2 over 2. Cancel out the 2's. So that would just be equal to root 2 as well. So that's equal to 2 over root 2. That also simplifies to just root 2. All right. So once again, I hear this. I hear some bursts of confusion. So you got to find the angle, find the side lengths on the right triangle, and then figure out what the ratios on the right triangle are going to be. And you have to divide fractions still.
What did you write the top part of the fraction?
Cosecant, that's 1 over root 2 over root 2. That's the hypotenuse.
No, what's to the right of 1?
This is HYP. Hypotenuse over root 2 over root 2, which is the opposite. So these are reciprocal. The sine of 45 is opposite over hypotenuse. The cosecant of 45 is hypotenuse over opposite. So you would flip your numerator and denominator. The cosine of 45 is going to be the same thing. The cosine of 45 degrees is equal to root 2 over 2, that's the adjacent side, over 1, that's the hypotenuse, so that's equal to root 2 over 2. The secant is, once again, just like the cosecant, the secant of 45 degrees, that's equal to 1, the hypotenuse, over root 2 over 2, the adjacent side. So 1 over root 2 over 2, that's equal to, once again, 2 over root 2, or root 2. All right, so I'm going to clear annotation so you have a long delay. Roy, Plant. Clear annotations. Follow along on your screens, right? So there should be like a 45-second delay so that you can keep up on YouTube Live.
I like that.
You go live on Twitch.
What's up?
You go live on Twitch.
This isn't. I mean, I feel like that's more for video games.
No, there's an IRL section.
Really? No.
I think you can just like, when they turn on chat, not just spam POG chat, right? Can we do super chats on this YouTube?
All right. So tangent. The tangent of 45. All right. What's the value of the opposite side? What's the length? So the tangent is the opposite over the adjacent. What's the value of the opposite side? What's the length of the opposite side? For 45. For this triangle. What's the opposite side here? Root 2 over 2. What's the adjacent side? What's anything divided by itself? So the tangent here is 1. The cotangent, instead of the opposite over adjacent, it's the adjacent over the opposite. So what's the adjacent side? What's the measure of the adjacent side? Root 2 over 2. What's the measure of the opposite side? What's anything divided by itself? 1. Yeah. Oh, yeah. Clearing annotations. You still have like 40 seconds to get it down on the live stream.
You just paused it.
Yeah.
What's the price do on this one?
Yo! That's so cool.
What?
Can we do that if we need to pick a random number? Oh, 5 died.
Speed? What? Oh. Whoa.
That is epic. That is cool. Wait, what?
I don't know, man, but that's cool. Right?
All right.
Is that in the lesson?
We are not. I wish probability was in pre-calc. I love probability. Okay. So, we have a 30, 60, 90 degree triangle now. 30, 60, and the right angle is 90. To find the side lengths of a 30, 60, 90, we know the hypotenuse is 1, but we need to find our values right here. Let's derive our values. Let's derive what these values and these values are. To do this, I'm going to get an equilateral triangle. This equilateral triangle is a 60, 60, 60 degree triangle. Right? So all values of this triangle are 60, which means the side lengths are 1. All right. For those who are who have a good memory from Friday's class, what am I going to do to this right triangle? Split it. Split it in half. Yeah. That's all right. That's why we're doing it again. That's why we're doing this again. The right triangle value is 90. Okay, so when you split this down the middle, you create right angles right here and right here. And this is a 60 degree angle cut in half. Half of 60 is 30. So now we've created 30, 60, 90 degree triangles. Now, this side originally had a length of 1, but we cut it in half. So now, this length is 1/2. So now we have 1 and 1/2, and we need to find the height of the triangle. So I'm going to call the height x, and we can use the Pythagorean theorem, because a leg squared plus x squared equals 1 squared. 1/2 squared plus x squared is equal to 1 squared. All right. What's 1/2 squared? 1/4 plus x squared is equal to 1. Now, x squared, that means x squared is equal to 1 minus 1/4. What's 1 minus 1/4? 3/4. So, the square root of x squared is equal to the square root of 3 over the square root of 4. The square root of x squared is x, and the square root of 3 is the square root of 3. We can't simplify that, but the square root of 4 is 2. So x is equal to root 3 over 2. So this value right here, opposite of 30, that is 1/2. And the value opposite of 60 is root 3 over 2. So let's find the sine of 30. What's the opposite side? What's the side opposite of 30? So for 30 degrees, what's the length of the side opposite 30 degrees? 1/2. Opposite 30 degrees is 1/2. That's equal to 1/2 over what? What's the hypotenuse here? 1/2 over 1, so that's equal to 1/2. That's the sine of 30. The sine of 60, that's equal to, what's the length of the side opposite 60? So that's root 3 over 2 over 1. So that's equal to root 3 over 2. The cosecant of 30, and the cosecant of 60 is going to be 1/2 over 1. So sorry. The cosecant is the hypotenuse over the opposite. So for 30 degrees, the opposite side is 1/2. And the hypotenuse is 1. But the cosecant is hypotenuse over opposite. So that's 1 over 1/2. Let's turn off that audio. You don't need to have audio coming from your devices. 1 over 1/2, that's equal to 2. The cosecant of 60 is 1 over root 3 over 2. So that's going to be equal to 2 over root 3. Flip the fraction. Which multiply each side by root 3 over root 3. That's equal to 2 times root 3 over 3. So that's going to be 2 root 3 over 3. 2 root 3 over 3. Either one. Try cosine. Alright, so you guys try cosine.
So the 5.
Yeah.
So why by
Well, just keep the phone away. That way.
Hello. I heard the breath. Hello.
You just go to YouTube, Nick Lal. Go to live stream. So you go to the opposite over the adjacent. Side opposite 30 is 1/2. Yes, Ty. When Claire gets back.
But yeah,
I like that, Justin. So, should be. It should be the one that's live streaming. Yeah. Yeah. Yeah.
Get 1 over square root of 3.
So the opposite side of 30 is 1/2. The adjacent is root 3 over 2. So you have 1/2 1/2 divided by root 3 over 2, which is equal to 1/2 times 2 over root 3. When you divide fractions, you can multiply and switch the numerator and denominator. The second one.
Can you scroll back up to the triangle?
What was that?
Can you scroll back up to the triangle? I want to make sure
I cleared annotation. So the side opposite 30 is 1/2. The side opposite 60. Here, I mean, go back. You should do the work of deriving the sides. 1/2. Well, that's 1/2. Oh, yeah. That also that side needs to be 30. That side needs to be 60. But yeah. Yeah. All right. Try evaluating. Try finding the doing the problem on page 3. If you're not done yet. You might need to use the Pythagorean theorem to find the missing side and then find the trig values. Yeah. That. So it's the pick the bottom left. Yeah. So this is theta right here. Yeah. Oh. Sorry, there. It's kind of not good. I'm gonna make some new ones tomorrow. All right. Yeah. Okay. So what we have to do is plug 0.5 in for x, and the polynomial has to be equal to 0. So set p of x equal to 0, plug in positive 0.5.
Thank you.
All right, so what's the side opposite theta? What can we call this? So that side is 5. What's the hypotenuse? All right, so x squared plus 5 squared plus 6 squared. Sorry. X squared plus 5 squared equals 6 squared. So x squared plus 25 equals 36. X squared is equal to 11. And x is equal to the square root of 11. So you have the square root of 11 right here. All right, so the sine of theta is going to be 5, 6. The cosine of theta.
you can do it the cosine in that box below.
I prefer having the 3 main trig functions in the top 3, the reciprocal in the bottom 3. The cosine of theta would be root 11 over 6. The tangent of theta, that's equal to Yeah, that's cosine. Alright, opposite over adjacent, that's 5 over the square root of 11. The cosecant of theta is going to be 6/5. The secant of theta is going to be 6 over the square root of 11. And the cotangent of theta is root 11 over 5. So notice some patterns here. So you're in here degree mode. So for the next section, make sure you're in degree mode. You hit mode, and then you hit degree. So you see mode, that's going to be below your window button, and you're going to set degree. So you can, let's pull up the calculator here. You would hit mode. So sorry, first you have to turn the calculator on. And after you turn it on, you would hit mode, and then make sure you're not in radian mode, but that you're in degree mode. The tangent of 90 degrees, you should find that it's undefined. So the cosine of 30. That should be that should be root 3 over 2. But when you approximate that in your calculator, you should find that the cosine of 30 is 0.8666. Also find the root 3 over 2. But also evaluate the root 3 over 2. See how they're similar. So the cosine of 30 is approximately equal to 0.866, but is precisely equal to root 3 over 2. Yeah. Yeah. No, find root 3 divided by 2. Cosine of 30 and root 3 over 2 should be equivalent. The tangent of 90 should be undefined. So check out for your calculator. Find the square root of 3. Check out the calculator. Divide it by 2. That you should get 0.866025438. So the cosine of 30 is 0.866 0.0254038, and that's equivalent to root 3 over 2. So we don't have a cosecant. We don't have a cosecant button. But how can we find cosecant in terms of sine? How is cosecant of theta related to sine of theta? You can look at DeMarco. Let's lift the head up. All right. How is cosecant of theta related to sine of theta? Flip. So what did I write for on the first page? How cosecant is related to sine? One over the sine of theta. So cosecant of theta, that's 1 over the sine of theta. So if we need to evaluate this in our calculator, we evaluate this as 1 over the sine of 45. All right, well, I'm gonna try to one divided by the sine of 45 degrees. All right, so that should be equal to about 1.41. All right. All right, the sine of 45. Once again, this is kind of plug and chug. The sine of 45, 7.07. The sine of 15, 0.258. Cotangent of 45, that's going to be 1 over the tangent of 45. So that's going to be 1. Yeah. Yeah. All right. Let's figure out how we could solve a triangle just from the hypotenuse and an angle. All right. Vanez, flip that head up, please. So this one, we have to use some logic here, and you're going to have to use your calculator. So our central angle is 36 degrees, and our hypotenuse is 8. How could we find our opposite side to 36? How can we find our opposite side? Well, how can we use a trig function to find this opposite side? We'd have to, if we have 36 and 8 is the hypotenuse, we need to find the opposite side. What could we do? What trig function could we take of 36? Well, what trig function? So what are our trig functions? Sine, cosine. What trig function could we take of 36? Which one do you think would work best? Sine. If we take the sine of 36, what is the sine of an angle? Opposite over the hypotenuse. All right? So it's the opposite over the hypotenuse. What's the opposite side equal to? Let's call this opposite side x. So what do we have for the opposite side right now? X. What's the hypotenuse? 8. So what can we do to isolate x? Multiply each side by 8. So now, 8 times the sine of 36 is equal to x. Now this is where our calculator comes in. 8 times the sine of 36. That's 4.702. 4.702. All right? So now, we need to find this degree measure. How can we find this degree measure right here? This degree measure, what can we do to find it? It's a triangle. How many degrees are in a triangle? 180. All right, but what can we take away? 90. All right, so that's 90, right? And then we can take away 36. Yeah. $54 degrees. So that angle, can we turn off the audio, please? You don't need to have audio on. $54 degrees. Now, that's 54 degrees, and we have 4.702. How could we find our last side length? What's up? How can we find this side length right here, purple? What could we do? If you had to find this side length and this was a test, what would you do to find this side length? Yeah, you could, there's two ways to do it. You could find the cosine of 36, or you could use the Pythagorean theorem. So, one way to do it is the cosine of 36 is equal to, let's call this z, equals z over 8. Then 8 times the cosine of 36 is equal to z. Then you just take your calculator. 8 times the cosine of 36, that's equal to z. So that's 6.47. So z is equal to 6.47. So now we have all the side lengths of the right triangle and all of the angles of the right triangle, only given one angle and the length of the hypotenuse. Without trig, you wouldn't have been able to find that. Also, I do want to note that you could have found this side length by doing the Pythagorean theorem. 4.702 squared plus b squared equals 8 squared. Because we use trig to find one of the side lengths, once you have two side lengths in the right triangle, you can use Pythagorean theorem. But if you only have one side length in an angle, you'll have to use right triangle trig. All right. Let's do an angle of I'm going to walk you through an angle of elevation problem, and then you guys are going to try the other two. All right. So for angles of elevation suppression, it's best if you can visualize the problem. All right, create the triangle and find the value. So you have Roger is 340 feet away from the building. The angle of elevation to the top of the building is 65 degrees. Find the height of the building. So let's draw a building. How tall is the building? How tall is it? Well, it's x, right? So we don't know. So the height of the building is x. All right. Now, Roger, I'm going to say Roger is right here. This is Roger. Roger. Okay. What's Roger's angle of elevation to the top of the building? 65 degrees. 65 degrees. And what's the distance from Roger to the building? 340. So, Roger's 340 feet away from the building. The angle of elevation is 65 degrees. So that's, 340 feet. How can we find the height of the building? All right. Because tangent, all right. So the tangent of what angle? The tangent of 65 degrees is the opposite over the adjacent. So what is the opposite side of 65? X. X over 340. So that's the 340. That's the adjacent side to 63 or 65. So I'm sorry. So now I multiply each side by 340. 340 times the tangent of 65 is equal to x. Now, to find x, I got my calculator. 340 times the tangent of 65 is equal to x. So that means that the building is 729.13 feet tall. X is equal to 729.13 feet. All right. Use this example to try example 2 and 3. And I'll give you some help, at least drawing them, if you need. Was that? Yeah. Yeah, you want to subtract, find the two distances, and then subtract. But you want to subtract the big, obviously you want to subtract the bigger number. Smaller number from the bigger. Yes. You have two people, right? One, you got one person, so that's great. Now another person. One is 30 degrees, the other is 60 degrees. So you're going to want to solve two problems. Solve for 30 degrees, 300,
Oh, right,
60 degrees, 300. So y use tangent, right? And then whichever one is bigger is going to go farther away. And then the distance here is going to be the larger distance minus the smaller one.
Oh, I'm thinking you're saying.
Mr. Law,
Yeah.
can you check this word, please? Because I got an answer on
I'm thinking there's decimals.
Here, I'm going to start setting up the.
So, can you
Yeah, you can also, you can also use tangent as long as you. But in your calculator, it's easy to put in.
okay, hold up. Alright, so,
Way too good.
I was too close. I don't know why.
It does. It's such a part. Right? Even really after that point.
Dude, she's like over 5 miles away. Does that sound accurate? Mr. Law, 5 miles? No? Okay.
Maybe she just has some really good vision.
Maybe she's not. Oh, I forgot.
Make sure you're in degree mode.
That's a big range.
Bloody. That's that was yeah.
Yeah, that's pretty easy.
Oh, so I got everything right, but oh, okay, so that's see now stuff like that doesn't make you feel bad. See, like now I got everything wrong. I was like, now I just
Oh my god, that's a zero? No, I will.
Alright. You guys need some help visualizing the third problem?
Oh, yeah, big. Fair. Yeah.
Yeah, yeah, so you want these to find the y that
Oh, yeah.
Alright. Need some help visualizing the third problem? Miles, put your phones away. Catch up. So, the last one. This length is 200. What's our angle of depression here? Our angle of depression should be 37, and the 40, right? So you have 37 degrees here, and 40 degrees here.
and I said
So, you could use the tangent function to find the height of both triangles, and then the height of the building is adding the two up. Yep. We're right here. So this is 300. So that's 519.6. So that's so if you did.
I'm gonna try though.